This is Maths with Ace by Mr. Kamotho, and in this video I want us to explain activity 4. We are still talking about trigonometry, and we now want to explain a scenario, or what we are going to call the ambiguous case. The ambiguous case means it is not clear. We can have two situations with the same kind of instructions or facts. For example, in this activity, we are having a triangle, two triangles, as you can see there. For a triangle, when the length of two sides and the size of a non-included angle are known. We know two sides, and there is an angle which is not included in between the two sides. For example, we have this side 7 and this side is 6 centimeters, and a different angle which is not included, like here we have 50. When that is the condition, it is sometimes possible to find two values for the length of the third side. Two values for the length of the third side. This is called the ambiguous case. For example, if we have this length 7 centimeters, and this is 50 degrees, and this is 6 centimeters, we can have that triangle ABC, and you can see this angle is obtuse. It is greater than 90. And we can also have 7 centimeters, 50 degrees, 6 centimeters, and we can have that line 6 centimeters cutting the line AC, not at this point now, but at this point. We have two different triangles. And I just want to construct the two triangles practically so that we can exactly see what the conditions are. We have two triangles, and let us say if we are faced by a situation that looks like that. This is a line segment. We can talk about this is point A. Point AB is 7 centimeters. Let us measure 7 centimeters. 7 centimeters is from here all the way. That is 7 centimeters, as you can see. That is, we have 7 centimeters. That is it. That is 7 centimeters. From this corner, let us cut the 7 centimeters from that edge. 7 centimeter. We are having a mark there. And at this particular point, at point A, we have to measure an angle of 50 degrees. Protractor now. Place the protractor at point A. There. And we have angle. This, by the way, is point B. Let us have point C. There is 50 degrees from here. The angle here is going to be from here, 50 degrees here. That is the line which is going to connect A and the possible point C. Let us have it there. Let us have it there. Now, we need now to create, we don't know where C is along that line. We need to create a line segment which is now, this is already 7 centimeters and this is already 50 degrees, as we have seen. We need now to have a line BC, which is going to be 6 centimeters, and 6 centimeters is simply going to be from this edge, 6 centimeters. That is it. That is 6 centimeters, as you can see. Now, from point B, using the 6 centimeters now, we can have a line segment cutting there. If you draw that triangle, then cutting over there. So you can already see we have two triangles. We can have, this can be point C1 and this can be point C2. So using the two, we can complete our triangle that way or this way. You can now see, you can have two triangles that way or that way. So if we can just now talk about, this is 6 centimeters and this is also 6 centimeters. If we want to talk about the triangle ABC, we can talk about triangle ABC or triangle ABC. And as you can see, we have two situations. The thing is, what about if we can just deal with triangle ABC1 here and create ABC2 here? We are going to start again from point A. From point A, we measure 7 centimeters. Let us have a ruler. 7 centimeters. Yes, 7 centimeters. 7 centimeters. Let us have 7 centimeters. Let us have 7 centimeters. Let's see. From 0 to 7. There we are. 0 to 7. Then this is 7 centimeters. Let us now have angle 50 degrees from point A. 50 degrees from point A. Exactly there. So 50 is along that line. All the way 0, 10, 20, 30, 40, 50 degrees along that line. And let us now have a line joining that. That is true. And if we can now have the length of 6 centimeters, this is, we believe, 6 centimeters. Let us confirm about that. This is 6 centimeters. Yes, that is 6 centimeters. If we can just have it here, we can have that arc. So we have two triangles. We have C2. Now we can deal with two triangles. We can deal with two triangles the way we have seen. And let us now, that is an ambiguous case. That is an ambiguous case. So this is 7 centimeters, this is 6 centimeters, and this is 50 degrees. There we are. It is an ambiguous case. Assume now you are not seeing C2 here. We are just seeing ABC1. This triangle and this angle is an obtuse, greater than 90. This angle is acute. Now, the question is, we have actually constructed the two ambiguous cases, and the question now continues. The arc centered at B cuts the line A from A to C at C1 and at C2. This is an example of an ambiguous case where two triangles can be constructed from the same facts. We have followed the two facts and you have come up with the two triangles. Show by calculation that AC, which is AC1 is 1.8 centimeters and AC2 is 7.2 centimeters. Show by calculation. And we are not far from that. And let us just see what would really happen. Now, we know very well that we have 6 over sine 60, which can also be, we don't know this now, which can also be 7 over sine C2. let us 6 over the sine of 50 degrees is equals to 7, which we know, over the sine of C. And by this, we can already tell that angle C, we have 6 sine C is equals to 7 sine 50 degrees. Having said that, we can already see that sine C is 7 sine 50 degrees all over 6. And angle C is the sine inverse of the whole of this now. 7 sine 50 all over 6. So we need to get the sine of the value of C. So let us have 7 times the sine of 50 degrees, close bracket, equals to, divide by 6, giving us 0.89, and then the shift sign of this, shift sign of answer, then we get 63.3 degrees. So angle C is 63.3 degrees. That is acute angle, meaning that it is less than 90 and it can only appear here. This is 63.3 degrees. What we need to understand is that this angle here is greater than 90 degrees but less than 180. One fact that we have to understand at this particular point, and it has to be noted with a lot of concern, is that the sine of supplementary angles are equal. The sine of supplementary angles are equal. What do I mean by that? The sine of supplementary angles are equal. For example, if we are talking about the sine of 30 degrees is exactly equals to the sine of 180 minus 30 degrees, which is the sine of 150 degrees. Please note, two supplementary angles add up to 180 degrees. That means if you want to know this angle, it is now 180 minus answer. So this angle is 116 because 116.6 plus 63.3, it gives us 116.7. This angle is now this small angle here, which is greater than 90 degrees, is 116.7 degrees. And let us now just look at it. So if we now want to talk of, if this is then 63, if this is 63.3, what is this angle? Let us calculate. 63.3 plus 50, which gives us 113, minus 180 minus answer, then this angle is 66.7. This angle becomes 66.7 degrees. Let us know what is this small angle here. We have 116.7 plus 50 equals to that. Now 180 minus answer equals to 13.3. This is 13.3 degrees. Let us now have our argument. How do we prove this is 1.8 centimeters and this is 7.2? Because that is how the question is asking us. Of course, we know that if we say this is small side B, B over the sine of 13.3 is equals to 6 over the sine of 50. And we can see B is going to be equals to 6 sine 13.3 divided by the sine of 50. That is after cross multiplication. And B is, let us see, 6 times the sine of 13.3, which is that when you divide this one by the sine of 50 degrees, it gives us 1.8. So B is 1.8 centimeters. Confirmed. How then do we confirm this being 7.2? Again, we have to say that if we continue to call it side B because we don't know, and this is angle B, B over the sine of 66.7 is equals to 6 over the sine of 50 degrees. And again, after cross multiplication, B becomes 6, the sine of 66.7, everything over, of course, from here, everything over the sine of 50 degrees. And B becomes now, let us see, 6 times the sine of 66.7 equals to, you divide this by the sine of 50 degrees, it gives us 7.2 degrees exactly. So B is 7.2, not degrees, but centimeters. And we have proven that from the two ambiguous cases, then it is possible to have two different triangles, one of them with the same facts, but of course this length is 1.8 and this length is 7.2 because of the ambiguous cases. It happens, but the most important thing to note is that the sine of supplementary angles are equal. The sine, this is the most important point today. The sine of supplementary angles are equal. This is what we are talking about today. And I've given an example. The sine of 30 is equals to the sine of 180 minus 30, which is 150. The sine of 40 is equals to the sine of 140. Try that using the calculator, and then you will know that. Thank you, and let us meet in the next video.